Hi, Science 10, Lesson 2 on types of chemical reactions. Please go to your notes on page 18 because that's where our 5 kinds of, maybe 6 kinds of chemical reactions are listed. And we do need to know what these 5 kinds are. The first kind, very simply, is called either formation or simple composition, and that's when 2 elements form a compound. And in your notes, hopefully you don't have the strange question mark boxes that I have on this form of my PowerPoint that got put into Notability, so sorry about that. But basically, we're looking at the first one saying nitrogen and hydrogen are forming this ammonium. And so we've got 2 elements making a compound. This one is S8 and oxygen that forms SO3. Again, 2 elements are forming a compound. Pretty easy. Second kind is the very exact opposite of composition. It's decomposition. And this is when one compound is broken down into its elements. So in this case, this is peroxide being broken into hydrogen and oxygen. So it's a compound that breaks into its 2 elements. Over here, ammonia is being broken into nitrogen and hydrogen. Again, a compound being broken into its 2 elements. So far, this is elements forming a compound is composition, you're composing it. And this one, the compound is breaking into its 2 elements, that's decomposition. For the third type, this is very simply where an element and a compound will form a new element and a new compound by switching either the positive or the negative ions. So in this example, we have sodium and silver that are both the cations. So as we join these 2 together in order to make something new, we're just switching the 2 that are both the same charge. So when we do that, now the silver will stand alone because sodium is taking its place. It's just like a couple that's dancing, male and female, and the male takes a different female partner for the second dance. So it's just there's changing spots. So in this case, now sodium has to stand alone because chloride is going to bind with the sodium here. So there we have the element and compound, that element and compound that's forming a different element and a different compound. Next example, we have copper and sodium nitrate, and because these are the 2 that are the positives, they will be the ones switching places. So on the other side of the chemical equation, we see now that silver is by itself and we have to join copper with nitrate. What's going to be something you have to be careful of here is that when you're joining, making the correct chemical formula, we have to look at how you have to make sure that the charges are dropped and swapped all over again to make sure that the formula is correctly written. So that's something to keep in mind as we go on to predict formulas and the products later. Well, we've got, just to review, single replacement, element and compound makes a new element and compound. And in number 4, this one is where 2 compounds basically swap their components to make two new compounds. So this is pretty easy, where our two that are positives are going to switch places and make two new products. That's what that's supposed to be showing. So in this case, we have calcium with nitrate, but as the product, calcium will be with carbonate. And you just have to drop and swap. These both have 2s, so they would cancel out, so that's the correct formula. And now sodium is going to go with the nitrate. They both have 1 charges, so drop and swap, and NaNO3 is the correct formula. So you can see how 2 compounds swap partners to make 2 new compounds, and you can think about 2 couples that are dancing, and they will swap partners and dance with the other one. That's basically what double reaction is. Our 5th kind of reaction is where we take combustion of a hydrocarbon. So we have a carbon and hydrogen type of compound, and combustion means that it burns, and all of the rest of the formula will be the same for all of the hydrocarbon combustions. To combust hydrocarbon, you need to add oxygen, and it will always form H2O and CO2. So it's easy to predict what the products are for these. It's just sometimes a little more tricky in doing the balancing for hydrocarbon combustions. So here's an example of CH4, and you join oxygen to it, it makes CO2 and H2O. One thing that I will be hoping that you can practice as we balance hydrocarbon combustions is that the rule will be that the way that you see them in the formula, the carbon first, the H second, and the O next, that is the order that you balance them in, and that will make your balancing much more easily done. So we'll notice that the balancing, well, for this one is already complete, but for some of the ones that you will balance, this will make a world of difference to always balance them in the order that you see them: C's, then H's, then O's. So we will do some practicing on those coming up. I would like you to go to your notes and fill in those 2 pages about the types of reactions. By the way, anything that doesn't fit in the other 5 types, we would call it an other. So if there's a reaction that, for example, has 2 elements making 3 compounds, that would be considered an other. So in reviewing what you see on page 20 at the top, is that 2 elements that make a compound would always be simple composition, and we can just write SC for that. If it's a compound that breaks down into 2 elements, that's simple decomposition. We can write SD. For single replacement, that's an element and a compound making a different element and a compound for products, and that would be single replacement. So you're replacing the 2 that are the same charge. Double replacement means 2 compounds make 2 different compounds by swapping their components, double replacement. And a hydrocarbon combustion is any hydrocarbon that you burn, adding oxygen and forming CO2 and H2O, hydrocarbon combustion. If it doesn't fit in those categories, we can write other. So I would like you to use those symbols. Over here on the bottom of page 20 is our practice, and I just encourage you to follow as I go through these. Element and compound makes a new element and compound. So that one is single replacement. Here we have 2 compounds making 1. That would have to be an other because there is no category for that. This one has 2 elements forming a compound. That would be simple composition. I see this as a hydrocarbon that's burning. That's the combustion reaction. And this one has two compounds, swapping components to make two other compounds. That is double replacement. And double replacement can involve complex ions. That's totally fine. And NH4 is a complex ion. So this is not going to be confusing to balance if you keep that complex ion together. This one is a compound that's broken down into two elements. So that's simple decomposition. That is the practice on all of the types of chemical equations that there are. So my assignment to you will be to go to page 22 to page 24 and try at least 4 questions from each category and practice both parts of the question, which is to balance the equation and to tell the type of equation, just as we did up here, telling the types of equations. When I did these, I was not balancing, but you certainly could go through here and balance them as well. For example, number 3, if I look at the fact that there's 2 hydrogens and 2 chlorides, to balance number 3, I would have to add a 2 as a coefficient in there, then it would be balanced. So as you're working through your practice today, which will be starting on page 22 here, you can try to not only tell the type of equation, but you can, and in this case, they're pretty easy because it tells you they're all single replacement. All right. It's some of them, as you go on to page 24, it will be a mix. But these here are all single replacements, so that you're practicing how to exchange the one component in here and balance it that way. So I could do number 5 here, the first one with you, and you can see that we have 2 hydrogens on this side, and we've got 3 hydrogens on this side, so you need to make them both equal to 6. So I can add the coefficient of 3, meaning there's 6 hydrogen here, coefficient of 2, meaning there's 6 hydrogens here, checking off the hydrogens. This, though, means there's 2 phosphates. Remember, keep that guy all together as a complex ion. And so 2 phosphates on the left, meaning I need to add a 2 over here to make sure there's 2 phosphates on this side so I can check them off. This then makes 2 times 3, 6 potassiums. So I go back over here and make 6 potassiums. That, my friends, is a balanced equation for the first one. 4 of each. Of course, you can do more of those if you'd like, but I will be posting the answers to the first 4 in each category from page 21 to 24 in tomorrow's post. So keep balancing, try as many as you can, rewind this video if you need, and I wish you all well.